All right, so we've got another example here. This time we are looking at job stress. Again, we are saying, how do we know if it's a sampling distribution problem about means or if it's about counts? And we look through a problem and we see the word mean is nowhere in here, first off. We do have a percent that is same basically as a proportion. We are measuring the information, is your job stressful or not? So that is a success failure sort of criteria, categorical variable. All right, so we'll say categorical variable. And then we have 200 workers, so that's of course our sample size chosen at random. Okay, this is definitely a counts problem. So what we have the following pieces of information, right? A probability of success of 0.81, a probability that they have their job is stressful, a probability of failure that their job's not stressful of the complement, so 1 minus 0.81, 0.19, sample size of 200, and we are asking what is the probability that fewer than 160 find their job stressful? All right, so that is a less than 160, right? And so we know for our sampling distribution, so in this case, normally it's going to say, use the normal approximation to the binomial, or don't forget the continuity correction, or maybe both. Those are your keys to say, we're doing this with a normal approximation, right? If this problem were just given as a test question, you really could work it either way. You could work as a binomial distribution problem like you did in chapter 4, or as a normal approximation. But there will be instructions on the test that say do it one way, right? If it says normal approximation, you got to do it the way we're doing it now. All right, so we know for binomial that the mean of the binomial distribution is n times p, so that is going to be 200 times 0.81, which I think is 162, but we'll double check that in a minute. And the standard deviation square root of npq, so square root of 200 times 0.81 times 0.19, and we'll have to put that in the calculator. Sorry about that. So we want to know the probability that fewer than 160 find their job stressful. So we've already figured out the center is 162. 160 will be a little bit less than that, right? And of course, we're going to shade to the left, the less than side. Okay. Now, so I'm drawing my slightly exaggerated bar for 160. And the question is, well, is 160 included or not, right? And since this says fewer than, this means 160 is not included. And so that means our data value is not going to be 160. We're going to go down to the left side of the bar at 159.5 and everything below that. So we're going to use x 159.5. All right, so we have our drawing. We can calculate our z-score. Right, so our data value 159.5, our mean, assuming I did this right, of 162, standard deviation of 200 times 0.81 times 0.19. All right, so we've got to put that in a calculator or GeoGebra. Hold on, right there. All right, so we're just going to double check that my mental math was correct, and it was. Good. All right, so we're looking at 159.5 minus 162. We're going to divide that by square root of 200 times 0.81 times 0.19. All right, so our z-score, negative 0.4506. That's a good place to leave it. Negative 0.4506. All right, so what's the probability that our sample of 200 workers will have less than 159 say that their job is stressful? All right, so we've got to go look that up, right? So we're going to go to GeoGebra. and find that that probability of x less than 160, what is it going to be? So, oops, I keep doing that. There we are. All right, so negative 0.4506 for our z-score. Normal distribution, we're looking at the less than side. And so I'm going to put in my z-score that we calculated, negative 0.4506. We're going to make sure that I have that right. Yes, all right. And that is going to give us an area 0.3261. All right, 0.3261. There we go. And that's it. That's the end of this question. So practice is important. Drawing our little drawing for that, putting that bar that's on the border and then asking, do we want it included or not? And what does that mean as far as our x value is going to be for our z-score, right? Is it going to be 1/2 below that value or 1/2 above? And remember, that depends on which side you're shading, which side you're interested in, the less than side or the greater than side. All right, let's find, there it is. Okay, see you guys next time. Maybe.